Students who are present, please give your attendance in the chat box. The format must be enrollment number / full name / section / roll number. Finish giving your attendance and we will then start. Okay, few students I can see their names are not in the format of enrollment number. Please rename yourself only as your enrollment number. Those who are present, please rename yourself as only the enrollment number. Okay, because there will be a report generated where your enrollment number will be searched for. So your name in the meeting should be only your correct enrollment number. And your attendance format will be enrollment number / full name / stream section and your roll number. Give your attendance only once right now. Give your attendance only once. Those who are present, please give your attendance. Give your attendance only once. Those whose names are not in the format of enrollment number in the meeting, please rename yourself. Please rename yourself as your enrollment number. I can see few names which are not in enrollment number, which are names. So just rename yourself as your enrollment number and give the attendance in the chat box only once. Enrollment number / full name / section / roll number. Section will include your stream also. CS 3A 3B or EC 3A 3B, like that. Okay, so while you are giving your attendance, we will just do a recap of the previous class and then we will start with the new things. So previous day, we had started our discussion on the relational algebra portion. Now, today we will be doing a recap of what things we have learned from relational algebra with example, and then we will start with the new ones. Okay, so today we will complete the relational algebra, and if time is there, then we will start with the next portion, that is functional dependency normalization. And in the next class, we will start with SQL. Okay. So I hope you can see the screen. Suppose there is a table. What is a table? A table is a 2D structure that we imagine, which is made of rows and columns, right? Now, this way, that means this, this, and this, these are my rows. So rows, we also call them as tuples. We also call them as record, right? And here, if we look at the columns, then the columns are nothing but the attributes. That means by what property we are trying to identify the things present in the table. Now see, one more thing. A table is representing an entity set. We have learned the ER diagram. We have learned whatever is the present in my table. So table is my entity set. And what are my rows and columns? If you understand, then rows are my entity. Each row is one entity. One row, if you say one row, then one entity. Okay. And what are the columns? The columns are the attributes. Attribute means what? The properties about, means explaining the entity. So if I say that a student, so a student is an entity set. So it is present as a form of a table. A student is a table. Now you, your friend, suppose your classmate, your 75 classmates, each of them 75 rows will be present. So each column will each row will represent one student present in the class or in the section, right? Similarly, one student needs to be identified using either enrollment number or name or section roll number or suppose phone number, email ID, these things. So these things by which you are identifying one row out of a set of row, that is a table, is named as the attribute. So column wise, that means vertically, we are trying to represent the attributes, the properties of a particular entity. And row wise, we are trying to implement, or we try to represent the students individually. Okay, up to this is fine. So see, I'm going very slow and I'm trying to explain the aspects more than once. So please be attentive and try to understand. Okay, if you know, well and good, fine. If you don't know, please understand. You are learning your subjects in the semesters also, right? So we are trying to do it in this way, like you remember everything with example. Fine. Again, I say people are still now giving attendance. So if you have given your attendance, please do not repeat. Please give the attendance only once. Okay, please give the attendance only once. Next, we have learned two operations previous day. One is the selection operation and one is the projection operation. So selection operation is represented by sigma as a notation, and projection is represented by pi as the notation. So if I say that what is selection, what a selection does, a selection with a predicate as a suffix on a particular table name or a relation. A table is also called as a relation. So this is the format of writing a selection. So what exactly it is trying to do? If suppose you have a student table and you want to find out that how many students or which students are present in the table who belong to the, suppose, double E stream, electrical stream, right? So how you will do that? You will write it like select stream, or whatever your column name is, equals to, you have to select the double E stream, the electrical stream. So it's a string. So you have to put it into double quotes on the relation. Suppose the name of the relation is student. right? So this is how you will write. Now, what will come as the output? Suppose this is your table. This one is your table. And here you have enrollment number, name, stream, and phone number. Randomly, I have taken 4 columns. So in this stream column, you will have CS, you will have EC, you will have double E, and suppose you have BT. Randomly, I have taken 4. So what you require the details of those students who are working or who are studying in the double E department. That means what? You are trying to fetch this particular column. Now see here, when you write this particular query, select stream equals to double E from student, you are not having the provision to select in only enrollment number or only name or only phone number or stream, anything like that. The total row wise selection will be done. The total row wise selection will be done. Now suppose you want that I want to fetch the phone numbers of all the students. I don't have any criteria, but I want the phone number of all the students present. Now suppose I have to send an SMS mass to all the students that there is an event, suppose there is a competitive event present in your college where all students can participate. Any stream, any year, any section, roll number, anyone can participate. So there, if I have to fetch column wise, if I have to fetch column wise data without any selection, I have to fetch the column wise data without any selection, then I will go for project. That means project, here your column names from the relation R, right? So if I want to do so, here in my example, it will be now if you want to project more than one column, then you just put comma and you fetch it like this. Okay, so there may not be any order like in the table. If it is name and then first name is coming and then phone number is coming, so you have to write name comma phone number. It is not like that. You can write phone number comma name. That is also okay. So by selection, what we are trying to do, we are trying to select based on some criteria and we are selecting the total row at a time. If I am doing only select, only sigma. If I want the data from a particular column, then I am using project. Now there you can project more than one column's data also, but not any particular rows data. Column wise, all data will be projected. Fine. Now suppose, now I want that I need to find out the name of the student, who is studying in EC department. I want to find out the name of the student who is studying in EC department. Understand the problem statement first. I want to find out the name of the student who is studying in the EC department. That means what? I am trying to select this particular, or I want to print this particular cell only. I want to print this particular cell only. So in that case, what I have to do? First, I have to find out that who all are studying into EC department. I want to find out who all are studying into EC department, and then I will project the name only. Then I will project the name only. Understand this well, because we will do problems, you will face problems, right? Suppose your table is like this. Now you want to reach to this particular cell. Right? So suppose based on what? Based on this EC, CS, EE and something. Okay. So your criteria is stream equals to EC. Okay. Those whose stream are EC, from there you will select the names. Name of the students whose stream are EC. Right? Now, if I want to go by the stream equals to EC, stream equals to EC, that means I will be doing the selection operation. Stream equals to EC, how you will find? By the selection operation. So suppose this is selected, right? Suppose there is another column. Here also you have an EC stream student. So you require this one also. So if you write this query, this is row number 1, 2, 3, 4. If you write this query, the output will be row 2 and row 4. Understand this well. If you write this query, then your output will be row 2 and row 4. After that, this is your name column. From this row 2 and row 4, you will extract only the name. After you select this row number 2 and row number 4, then you will be selecting the name. Pi denotes projection. Yes, pi denotes projection. Now see, if on this you write pi name on the student table, then what will happen? The inner query always works first. Please understand, when you write a query in relational algebra, when you write a query in MySQL, any platform, your inner query will work first. So in this particular case, if you write it like this, let me write it fresh. The table is student table. I prefer writing from the right hand side. If you want, you can also do it on the left hand side. So my inner query is in the suffix stream equals to EC. Fine. Now on this, what will this one select? This will select all the total row. The row will have enrollment number, name, stream, phone number, everything. Now I don't want that to be my output. I want only name. So for a one column selection, I have to project. So this will be my final query. Okay. Now there can be some of the questions that why selection is coming inside and projection is coming outside. I am coming to that. First, have you understood this? How this one is coming, output is coming. Have you understood this? I want some answers. Yes, no. Fine. Now let us understand that why the projection is not coming inside. Now you can say projection may come inside. Now see, if I write in the projection, you cannot write a criteria, right? So under projection, you cannot write stream equals to EC. So under projection, you have to write the column name. So suppose now I write table is constant, student table. So if I write pi name, and on this, I will write the selection criteria, then what will happen? If I write the selection criteria, then what will happen? By this pi name from your table, if you write pi name, so as I have told, from the inner query, it will start working. So from the pi name, first this one will be selected. From the student table, if you write from the student table pi name, this means what? What will be this one's output? The name column. The name column is selected. Okay. Now on this will be the input for this particular query. Two are separate queries, right? So first this one is done. And then this one wants to work on the output of the inner query. So name column is fetched. Now on the name column, you are trying to find stream equals to EC. So your outcome from the inner query is just the names. Now from the names, you are trying to find stream equals to EC. Can you find that? Can you find that? Only name is fetched from the inner query. Can you find the stream equals to EC from there? No. So there, I hope you understand why I am writing the selection query inside and the projection query outside. If you write the projection query inside, then what will happen? Only name column will be selected. Now on the name column that is selected from the inner query, that will be the input for the outer query. Now in your outer query, you have stream equals to EC. There you are getting the input as only name. So will it work? No. Right? Have you understood? If you write it like this, if you write the query like this, what I have told, first the inner query will work. So your inner query is doing what? Pi name from the student. So name column is fetched. That means this one becomes this is your outcome from the inner query. So only name column is fetched. So within the name column, your stream equals to EC, this selection has to be done. So how this can be done if only name is existing? Stream is not present. So how stream equals to EC you can fetch? Right? So this is the way how you can say that why your projection is not coming inside and why your selection is outside. When the selection is inside, how it is working? See. When the selection is inside means this is your student table. This is pi. Stream equals to EC. Right? On this, this one is trying to work. Now what your selection operation does, if this is your table, then by the selection operation, row wise selection will be done. Row wise selection, suppose this is EC, this is CS, this is EC, and this is suppose BT. Suppose anything. So whenever, if you write this inner query, that means what? This total row will be selected, row wise selection is done. So this total row will be selected. I'm not trying to project anything, any column name or anything like that. So you see this and this is done. Now this becomes, these two rows are becoming your output of the inner query. Now on that, pi name. So this column is your name column. So from these two rows, this is one row having enrollment number, stream, name, phone number, and this is another row. These two are selected. These two are coming as the output of your inner query. Now from here, this name and this name will be fetched because pi name is working on these two rows. So the function of pi is to select one column's data, and the function of selection is to find out the row-wise data based on any criteria. So here my criteria is stream equals to EC, right? So stream equals to EC is trying to fetch two rows from my table, row number 1 and row number 3, suppose any random 2, 3 rows. After that, that output of the inner query is going as the input of your pi. So in the input of the pi, two rows are going. In those rows, you have enrollment number, you have name, you have stream, you have phone number of all the students, right? From there, as you are writing pi name, only name will be selected and it will be shown. Is it clear now? Few students were asking doubts on this. Why your sigma is coming inside? Is it clear now? Write yes or no something. If you have understood, write yes at least. Right, so Next, we will be doing some of the queries on the banking structure that we had previous day. Okay. So let us just look at the slide for the query. See here, the first one, find the name of all students who are in CS branch, like we have done for EC branch. Now see, find those account number where balance is less than 10,000. So let me just go to the structure. So this one is the structure. If you have forgot or if you don't have, please take a screenshot of this one. Here you see, this is a banking database where you have different tables like your branch, account, depositor, customer, borrower, loan. Okay, these are the tables. The gray marked ones are the primary key for that particular table. If you don't have any gray marked one, that is a weak entity like that. Projection will not be inside. Shayan Chakraborty, projection will not be inside. Projection will always be outside. It is not universal, but that is how your output is coming. It is not a rule, but how it is coming, I have shown you using both inside and outside, right? So I hope you have understood that why it is outside. Projection must be outside. Okay. Yes, so I hope you have taken the screenshot and other things. So let me just show you that how it is coming. Some of you may already know, but for the others, I will just show. Find the account number where balance is less than 10,000. So balance is less than 10,000 is my criteria and I have to find the account number, right? Now I hope you understand from which table, tell me, I have shown you the database. Now from which table we will work on? Which is the table? On which table we will work on? One student has answered. From others I will be fetching the answer. From which table we will be working on? Look at the database, find out the table where you have account number and balance. Yes, account table. So most of the students are writing it correct. Now, how we will be doing it? How we will be writing it? So criteria will come inside, right? So on the account table, so let me write it here. Balance is less than 10,000. So again, I tell you, if it is a mathematical type of query, right? So if you write after 10, if you put a comma, that will also not be incorrect. Okay, so you can do that. And what we will fetch? The account number. Fine. So this is your total query. This is not difficult. You have to just understand that what you have to write. Okay. Okay. So some students are also writing the query. Fine. So inside the inner query, you are fetching those rows which are having balance less than 10,000. And from those rows, you are trying to project the account number. Fine. Is it okay? Is this one okay? Fine. Next one. See, in the next query, loan number, you have to find out the loan numbers which are from the CP branch with an amount greater than 1,000. CP branch amount greater than 1,000. Right? So from which table we will do it? From which table we will do it? Which table is having loan amount and loan branch number? Which table is having loan amount and loan branch number? Why borrower table? One student have written borrower table. In borrower table, you have customer name. Right, loan table, correct, loan table. So how we will write the query? How we will write the query? So my table is loan table. What are my, here I have two criteria, right? So branch name, whatever is the name of the attribute given in the table, you have to follow that. Okay, you cannot make the table attribute names different. So branch underscore name equals to CP branch, and now you can write and like this, or you can put this, anything you can do. Amount is greater than some value, suppose 1000. I hope it is correct. On this, your loan numbers has to be fetched. So okay, loan numbers has to be fetched. So here you have two criteria, and the criteria, how you will write your criteria, you will write by concatenating them, because and criteria is given. So branch number is one criteria and loan amount is another criteria. Okay, fine, this is okay. I hope there is no problem in understanding this one. Next one, last one. Branch name and branch city with asset more than 1 lakh. Branch name and branch, do it on your own. Write it in the chat box. Branch name and branch city with asset more than 1 lakh. From which table you will do? Branch name and branch city. Where asset is, yes, branch table. So most of the students are writing it correct. Next, you tell me how to write the query. Write the query and tell me. Those who can, write the query in the chat box. Branch name and branch city, two things you have to portray. Where asset is more than 10,000, sorry, 1 lakh. So how you will write? So what is your criteria? Your table is branch table, right? Criteria is asset more than 1 lakh, right? What things you have to fetch? Branch name, comma, branch city, right? So here two columns you are fetching and the criteria is given. Yes, some students are writing it correct. Yes, some students are writing it correct. No problem in that. Okay, few students are writing SQL query. See, we are not writing SQL query here. So pi of branch name, comma, branch city. Yes, if the name of the attribute is branch city, then please write that, branch city. Inside the bracket, that is your inner query, your thing is, your criteria is asset is greater than 1 lakh from the branch table. Okay, so I hope it is clear to all of you that if two criteria factor are given, then you have to either write it by and, or you can write it by or, anything. And outside, if two columns and more than one column has to be fetched, then you can put comma and write. Is it clear? These things are clear. 2-3 types of query I have tried to show you. Is these things are clear? Fine. So I'm getting few of the yeses. So I hope they are clear. Now let us go to the slide again. We will learn something new. Next, what we have, you have the union operation. Okay. So see, in case of union operation, what we do, you can see here a diagram, and here it is showing that union means whatever you have in one table, suppose table 1 and table 2, whatever you have in table 1 and whatever you have in table 2, everything will come together if you perform union operation. Okay, so suppose you are having two tables. Suppose you have, this is your table 1, T1. You have two columns, A and B, and you have some data, something, okay? And you have another table, right? Suppose C and D, and you have some two data. And if you do T1 union T2, then A, B, C, D, everything will come and it will be fitted in a table, right? Now, if you have same name, then first from T1 and then from T2. Okay, so what happens in an union operation? If you see here, what happens in an union operation with example, if you see, if you have one table having ID and name and second table having ID and name, then this happens in union. So as you can see, ID1 name is Abhi, ID2 name is Adam. And in the second table, ID2 name is Adam and ID3 name is Chester, some random names. So you can see ID2 is repeated. In both the tables, you have ID2. In both the tables, you have ID2. So ID2 will appear only once in your resultant table. ID2 will appear only once in the resultant table. This is union operation. Now, if you want that your ID2 will be repeated, like if it is present in table 1, it will be occur once in your outcome. And if it is occurring, if it is present in table 2, then it will occur in the outcome again. So there you have to go by union all operation. You have to go by union all operation. So operation is same, everything will be clubbed together. But here, if you see, the outcome is the Adam with ID2 is repeated once. Okay. So if you want the duplicate values must be eliminated, then you use only union. If you want your duplicate values to stay, then you must go with union all. Okay. If you want your duplicate values to get eliminated, you use union operation, only union. If you want your duplicate values to get eliminated, then you use union all. If you have two different column names, then union will not be applied. So that I have just cutted this C and D and I have written A and B. Different column names cannot perform union operation. Okay, if you have different column names, then you have to do it by join, right? So columns will be selected first and then union operation will be done. Okay, few students are still giving attendance. Please stop giving attendance because I have some genuine queries. I am missing out on them. Don't give any attendance in the chat box from now. Okay, don't give attendance after this because it's already 9:45. Don't give attendance. Already after 45 minutes, if you are joining the class, then let it be. No need to give attendance. Okay, so this is your union operation. Now, if you just go by one example here, you see a table R and S. If you do R with S union operation, no, it's not about any common ID. It is not about any common ID. Common ID we will use in joins. In union, it is just very simple. Whatever data you have in table 1 and whatever data you have in table 2, both will be just collaborated together and seen. It's just combined together. Okay. So you can see here R and S. If there is any repetition, that will be eliminated. That will appear only once. So you can see A1 is repeated here, but A1 is shown only once. Now you see E5. E5 total row. The total row E5 is not repeated. In the second table, it is E4. So E5 and E4 are different rows, different existence. So E5 is also appearing and E4 is also appearing. Okay. Yes, union all keeps all the duplicates. These are the forms that we will use in SQL, but in SQL, the formation of writing is a bit different. Okay, so we will do SQL in the next class. Today, if we do, then you will be confused. So let us complete the algebra first. Okay, let us do the mathematical one first. Next one is the intersection operation. Now, intersection means something which is common in both the tables. So in R, you have these many columns. In S, you have these many columns. So total row, if you have common, the total row is repeated in both the tables, then that one will be in your output. Okay. So the intersection goes like this. T1 intersect T2. Okay, so the notation is like this in union and like this in intersection. Fine. So in intersection, if there is anything in common, that will be coming. So ma'am, F was before E. So why E5 is coming? Okay, let me check. F4 was before E, so why it is coming? So when it is when you are writing union, suppose in SQL and somewhere, it will sort it in alphabetical order. It generally does like that. Okay, so that E is coming before F. And as E4, it is coming at last because it is from the S column. Okay, because A1 was common with R, C2 is not given, but C2 is done here. D3 is common with R, so D3 is coming first. Now E4, E5 is from R, so E5 is given, then F is given as E4, that is the last one that is coming after it. Okay. Now in some of the cases, some of the versions, you will find that alphabetical sorting is not given, and in some cases it is given, so it does not matter. Actually, what matters is everything that is present in both the tables will come here in the output. Okay. In some of the versions, it is coming as alphabetical sorting. In some of the cases, it may not. Okay. Are these in SQL? These are also present in SQL. Whatever you are learning in algebra, everything will come in SQL, but the SQL query writing is different. And here the writing, whatever we are doing is using notations. Okay, in SQL, you will write union. Like in English, you will write union. And here we are writing in like using some notations. What is the notation for union all? In case of algebra, we are just writing union. In case of algebra, we cannot write union all. In case of SQL, we will write union all. Okay, by English writing. Two tables will have same names. Yes, same column names. Okay, now next one is difference. Next one is difference. Now see here how difference goes. Now difference is interesting. See here, R is one table and S is another table. Now if I do R minus S or R difference S, and if I do S difference R, things will be different. Suppose this is my R table having A1, B2, D5, E4, F7. Okay, and this is my S where I have A1, D5, E3. Okay. Now, if I do R minus S, then if any value of S is present in R, total column wise, total row wise, if any value of S row wise is present in R, that will be deducted and other values of R will be posted here. So see, A1 is present in R. Yes. So A1 gets eliminated. D5 is present in R. Yes. So D5 gets eliminated. E3 is present in R. E3? No. E4 is present, but E3 is not present. So what is the value of R minus S? A1 is eliminated. B2 remains. D5 eliminated. E4 remains and F7 remains. So this is R minus S. The value of S row wise, if it is completely present in R, that will be deducted. That will be eliminated. As simple as that. So as it is present, this one is eliminated. This one is eliminated. E3 is not present in R. E4 is present. So E3 means E4 I cannot eliminate. So E4 remains. Right? Now if you do S minus R, whatever value of R is present row wise, totally if it is present in S, then it will be eliminated from S and other values will remain as the outcome. So see, A1 is present in S, so it is eliminated. B2 is present in S, no. D5 is present in S, yes. E4 is present in S, no. E3 is present. F7 is present in S, no. That means this is my only outcome. Understand the difference. If I do R minus S or you write R difference S, same thing. And if you write S difference R, output will be different. If you write R minus S, whatever values present in R will be checked in, sorry, whatever value present in S will be checked in R. Okay. If the values called row-wise total values are present in R, then they will be eliminated and whatever rest of the values remain in R will be in your output. Similarly, if you do S minus R, reverse, S minus R, then all the values of R, whichever are present in S, then they will be eliminated from S and whatever value remain in S, they will be present in your output. Okay. So if you see here, the S minus R, you check S minus R. In R, you have 5 rows and in S, you have 3 rows. That does not mean that you cannot do S minus R. You can do. Whatever values row wise in R, if it is present in S, then they will be eliminated from S and the remaining value, if any, in S, then they will be shown in the outcome. So see here, A1 in R is present in S, so it gets eliminated. B2 in R present in S, no, does not matter. D5 is present in R, S, yes, so it is eliminated. E4 is present in S, no. F7 is present in S, no. That means A1 and D5 are cancelled because they are present in R. Only E3 is not present in R, so E3 gets reflected as your output. So you can see difference R minus S and S minus R. Then output are different. E3 এর বদলে যদি E4 থাকতো, E3 এর বদলে here if it is E4, yes, then will be eliminated from R. If it is E4, what he is asking, E4, if instead of E3, E4 is present, then E4 is present in R. So it will be eliminated. Right? Similarly, if you do S minus R, then this E3 is not present, right? It will be E4. So output will be null. Right? Yes, if no common values are present, then whole table will be displayed. Yes. If no common values, then nothing is eliminated, nothing is deducted, right? So everything will be shown in the output. Is it clear why R minus S is always not equals to S minus R? Right? Is it clear? Difference operation is a bit confusing, so that I am asking r minus s and s minus r, always they will not be equal. Okay. All right. So they are saying it is clear. Now look at the queries. Look at the queries. You have the database, you have the bank database with you, right? So find the name of the customer. First query. Find the name of the customer. Okay, ma'am, can you please show the intersection? Yes, I can show, obviously. This is intersection. A1, B2, D3, F4, E5. And A1, C2, D3, E4. So which are common? Common row-wise, which are common in both the tables? A1 and D3. So they are shown in the output. Okay, intersection. Okay. Now come to the queries. Don't give attendance. CSEH roll number 11. Please don't give attendance. Have I asked for? Why you are giving attendance around 10 a.m. of the class where it has started 1 hour before? Okay, I'll show the database once more. Those who have not taken the database for consideration, please take it. Take the database. Take a picture, screenshot, whatever of the database so that we can proceed. Okay. So let us go to the operations. Now you will tell me what operation it has. Find the name of the customers who have a loan. Who have a loan and, sorry, who have a loan or an account or both. Tell me which operations you will use, which tables you will use. Customers who are having loan, from which table you will get? Borrower table. Borrower table means they have taken loan, right? And account means which table? Depositor table. If they have account, then only they can deposit. Then depositor table or both. Yes, union operation. So how you will write it? How you will write it? Union operation of the customer names. So take customer name from borrower and take customer name from depositor. Why I am not doing it with customer table? Why I am not doing it on customer table? Yes, you can do it like that also. Borrower union customer, if you do. See, one student is saying borrower union customer. Are the column names same? Borrower union customer, if you do, are the column names same? No. Then how can you do borrower union customer? Column names must be same. So you take customer name from borrower table and you take customer name from depositor table and then you union them, make a union. Okay. Borrower union customer, why you are not able to do? Because in borrower table and in customer table, if the column names are same, then you can do. If the column names are not same, then you cannot do. Okay. Show the, ma'am, please show the question once. Wait. This is the question. This is the question. In the depositor table, you have customer name and account number. In the borrower table, you have customer name and loan number. So the column names are not same, right? So you fetch the customer names and then you do a union, right? Is this one clear? column name এর ব্যাপারটা আরেকবার বলুন। Column name, if the column names are not same, then how can you do union? Union means what? Whatever value is present, we are just clubbing them together, right? So if it is customer name and loan number, and if in another table it is customer name and account number or amount, whatever, then how you will join them? Where the loan number will go? Some customers will not have loan number, so what they will do, right? So you cannot do it union like that. So how you will do? Fetch the customer name from the borrower table, fetch the customer name from the depositor table. So only customer names you have, then you club them up. Okay. Next one, next query, find the name of a branch who have account, but sorry, not name of branch, it will be name of customer. Customer who have account but not loan. Now tell me this. Name of the customer who have account but not loan. Which operation we will follow? Customer where we have who have account but not loan. Suppose, wait, some are saying intersection, some are saying difference. So which one? Wait, I'm explaining. Suppose here I have customers. Yes, most students are saying difference. Who have account but not loan. Who are having account, that means depositor, right? Suppose X, Y, Z, W. Fine. And this is my borrower table. Borrower table means those who are having loans. Suppose I have among these a person. Now understand logically, a person who is not having an account, can they take loan? No. That means whoever are having account, among them only some of them will have loan. Now everyone doesn't have loan, right? So suppose these two people are having loan, right? So these are the people who are having account, and these are the people who are having loan. Now in the loan table, you cannot have an A. You cannot have an A unless and until you are having A in the depositor table. Understand this first. Okay, many of you are answering. Stop answering and understand this. In the depositor table, I have all the customers. In the borrower table, I have all the loan handlers. Okay. Now, can there be any loan handler who is not having any account? It is not possible. Unless and until you are having an account, you cannot take loan, right? So the borrower table must have those customers only, among those customers only who are having an account, right? So if you say that Y is having a loan, okay, because Y is a valid customer here. If you say W is having a loan, that is possible because W is a customer here. But if I say A is having a loan, that is not possible because A is not registered as a customer here. So if A does not have an account, how can A take a loan? A cannot take a loan, right? So among the depositors only I will have borrower, right? Among the depositors only I have borrower, right? Now if I say, what was my query? Customers who have account but does not have a loan. That means what? From here I have a set X. Among them I can see this person has a loan, this person has a loan. But my query says the person who are having account but not having loan. That means X does not have a loan, Z does not have a loan. So this becomes my answer. So which type of query will give me this? Which type of operation will give me this? Your intersection, if you take the students who are taking intersection will take me this set. That means the ones who are having loans, the intersection will give me that. So it is not intersection, it is difference. It is difference. Have you understood? Now the people who were telling that why I am taking intersection, why not I can take intersection, have you understood? Yes, it is difference. Have you understood? People who few students have taken difference. Why it is not difference? Sorry, why it is not intersection? Have you understood why it is difference? Here, why you will perform union? Oh my God, why you will perform union? One student is telling me with enrollment number 1123 is telling me that you have union. Why in uni you are performing union? Okay, in the previous question is already done. Previous question is already done. In this question, how we will do that I am explaining. Here what we will write? Pi customer name from which table is bigger? Depositor minus pi customer name from borrower. Now see, reverse you cannot do. From borrower you should not minus depositor. That will not help. From depositor you have to minus borrower. Yes. Depositor minus borrower. Borrower minus depositor do not write. Okay. Now is it clear? This query is done. Fine. Who have loan? No, reverse is not possible. As I was telling, if you include a person who is having a loan, but that person is not included in the depositor, that is not possible. Right? We use union intersection in selection. Yes, union I have done in the previous problem only. Right? Okay. Now the last one. Find the name of the customer who neither have loan nor an account. Who neither have loan nor an account. Now tell me. Who neither have loan nor an account. Yes, reverse will give null. Neither have loan nor account. Some people are telling intersection. If you look at the query, if you look at the database, you see we have a customer table where every customer is enlisted, right? So if I write the query like this, pi customer name from customer table, the mother table, who have all customers, minus pi customer name from depositor, means who has account, union customer name from borrower. If I write it like this, what my inner query is giving me? What my inner query is giving me? Customers having account and having loan. Customers who are having account and who are having loan, that is given by my inner query. And what my outer query is giving? All customers that I have in my bank. So if I do a minus, that means what? All customer means suppose A, B, C, X, Y, W, Z. This is all customer of my bank. All customers of my bank. Now suppose accounts, who all are having accounts? A, B, C, Y, W is having account, right? And only C and Y are having loan. C and Y are having loan. That is possible. That means this this union query is giving me what? A, B, C, Y, W. Right? This is my inner query is giving me this customers who are having accounts, some random customers, and customers who are having loan, some random customers. Now, if I do an union, that means what? Customers who are having loan plus customers who are having account, that is done. Now, after this, I have all the customer as this as a set. Now, if I do a minus, that means I get what? B is one customer and X is one customer who are not included in my depositor table, account holder table, and who is not also, sorry, this is C, not B. This is X and Z, right? They are not having any account, they are not having any loan, right? So how I am getting this? First, all customers I am taking first, and in the inner query I am taking the depositors, that means the person who are having account, and the borrower, that means the person who are having loan, right? So I'm doing an intersection, that means customers who are having account plus customers who are having loan in the inner query. In the outer query, I am taking all the customers. So I have in the all customers, I have 1, 2, 3, 4, 5, 6, 7. Here I have 1, 2, 3, 4, 5, and among that 4, 5, 1 and 2 are my loan holders. So if I take this, then this becomes my set who are not having any customer account or who are not having any loan, right? Now you can say that, ma'am, within the depositor table, some of them are borrower. Within the depositor table, some of them are borrower, right? So if I say that a customer who is not having a account but not having a loan, that is not possible. That means this union, even if you don't do this union, only depositor table, if you fetch the customer name from the depositor table and you do a minus from the customer table, then also the same result will happen. You see, if I don't do the union, because C and Y, they are already present in the account holders table. Loan holders are somehow account holders also. The loan holders are somehow your account holders also. So even if you don't do the union, the result is coming same. Even if you don't do the union, the result is coming same, right? So you can do it like that also, or else, to be very, very clear, you can do the union. Query is not wrong. Okay. So neither having an account nor having a table. Is it clear? People who are saying the intersection and all, for them, is it clear? When we need to use project, oh my god, now a person is asking when we need to use projection, when to use selection. Oh my, projection you have to use when you have to select or when you have to take one column's value, and selection you have to do when you have an criteria, and based on the criteria you are taking the total rows value, right? Suppose, let me give you an example. Wait, you have, wait, I will just explain. Suppose you have a table, you have A, B, C, D, 4 columns. Okay. And you have 1, 2, 3, 7, 5, 2, 3, 7, 4, 1, 2, 2. Right? So A, B, C, D are your column names, and 1, 2, 3, 7, 5, 2, 3, 7, 4, 1, 2, 2. These are your rows. If you have to select one like this, suppose select those rows whose values, D values are 7, then these two has to be selected. So there you will write, suppose this is your T1, table 1. So how you will write on T1, D equals to 7. 7 is an integer value, so I'm not putting double quotes. If you have to go by this column wise selection, so pi B comma C from T1. Okay. So this is how you do selection and this is how you do projection. Okay. Now see, if you have to select only the B value for those whose D equals to 7, you have to only fetch the B value for those whose D equals to 7. So how you will do that? Table name D equals to 7, their B value has to be selected. This is how you will write. Okay. I have also told you earlier in the student table, but I think you have missed that part. So is it done? Who, okay, name of the customer who either have a loan or an account. Either have a loan or an account. Yes, only customer from customer table only. Yes. I of customer from customer table only. Right. Okay. Okay. Next, we will do the division operation. First question, we have done union, but that yes. So we have not done union like that. How we have done union? Pi customer name from depositor union pi customer name from some other table. Okay, so union can only be done when your columns are similar. Fine. On the table, you will not do union or intersection until and unless the columns are same. This is the last query. Depositor and borrower are making the union and then they are being deducted from the customer. So the customer is having 7 entries. Depositor is having 5 entries. Among those 5 entries, 2 people are the loan handlers. Okay. Among those, only 2 people are loan handlers. So you can see here, either if you do the union, then also those 2 loan handlers remain in the customer. And even if you do not take those 2 as the loan handlers, if you eliminate the last portion, then also your depositor will have 5 entries. So you can directly deduct 7 entries from here and 5 entries from here. Your answer will be anyhow these 2. Okay, because loan handlers are always coming inside the depositors. Instead, you don't have one, what do you say, one account, you cannot have a loan, right? Okay. Fine. So I hope this is done. Next, we have to move to the next portion, that is our division operation. Okay. So division operation, I don't have anything in the slide. I will just explain it here. Division. Understand this very carefully. Division is also confusing. Suppose you have 2 tables. One you have, suppose table A is having m plus n degree, right? And table B is having n degree, right? Then if you do A divided by B, if you divide A by B, your answer will be of M degree. What is degree? Column. Column numbers. Okay, degree means nothing but column numbers. Right? So how this M is coming? M plus N minus. Okay. So this is the funda in division operation. A is a big table who is having M plus N degree. B is a small table who is having only N degree. Okay, degree means column, number of columns. Okay, degree means number of columns. So if you do A divided by B, then only M will remain. Okay, so let us take example. Suppose A is having S number and serial number and product number. Okay, S1, P1. Okay, so let me take a bit of big table. একটু বড় table নিচ্ছি so that you can understand. So P2, P3, P4, P5. Suppose take P6 as well. Okay. Then you have S2. S2 to suppose I have P1 and P2. Okay. Then suppose you have S3. Okay, let me write it here only. It's in continuation with this S number, P number. So S3 is suppose having only P2, suppose randomly. S4, then I have, suppose S4 is having P2, P4, P5. This is my A table, total in continuation. Okay. So this is my A table. Fine. Suppose my B table, if I have in my B table P1, only P number is P1. This is my B table. And if I do A divided by B, see where I have P1, I have P1 here, I have P1 here. Do in anywhere I do have P1? No. So my result will be S number, P number, M, N, M plus N, and here you have N. So what is left? S number. P1 I have find twice. So this is my corresponding value of P1. This is my corresponding value of P1. So the value remains S1 and S2. This is my answer. Understand this well. Here my M is S number. Here my N is P number, right? So A has got both S number, P number, and B has got only P number. So what my AB will have? AB will have only S number. What was the rule? This is the rule, M plus N in A and B is only N. So what is the degree of A divided by B? M plus N minus N. So M. So here is your, understand this well. This is suppose case 1, only one case. Yes, I am explaining. First you understand this one. Two tables A and B. A is having M plus N number of columns and B is having N number of columns. What if A divided by B? A divided by B will have M number of columns. So M plus N minus N. So M number of columns. Okay, this is the column number wise criteria. Now see, A is a big table, so S1 is repeating itself for 6 times, P1 to P6. S2 is having P1, P2, S3 is having only P2, S4 is having P2, S4 is having P4, and S4 is having P5. Fine. Now in B table, I have only P number, that is P1. Now if I do A divided by B, I will search that in A table when my P1 is occurring. So P1 is occurring once here and once here. I have just encircled them. Now with respect to P1, what is my value of S number? Because S number is my output in A divided by B. So S1 and S2. P1 is occurring once for S1 and once for S2. So S1 and S2 are my outcome. Okay. Let me take another example. Suppose A is constant. Take the screenshot of this one. Take the picture or screenshot of this screen. Take the screenshot of this screen. Okay. Now, suppose my B table in case 2. This is my case 2. My B table is having P number as P2 and P4. P2 and P4, right? So when my P2s are occurring, I'm doing it as boxes. P2, 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 P2. Okay. So 4 P2. So in P2, what I have got? S1, S2, S3, S4, right? So in P2, I have got S1, S2, S3, S4. Then P4. So what is there in P4? This is the first P4. Any other P4? No. Here P4. So here my S1 is my P4's value and S4 is my P4's value. So S1, S4. Okay. Now what is my output of A divided by B? The common values that I have in P2 and P4. So S1 and S4. So what is my value? S number, S1 and S4. Okay. So this is how you do your division operation. Yes, this is how you do your division operation. Okay. Means you can think it like this. Suppose you have a value in A and a value in B and you divide it and your value remainder remains 0. So exactly what values do you have? S1 P2 and S4 P2 and S1 P4 and S4 P4. So this one, this one, this one, and okay. Done. If you want, let us take another example. Case 3. Suppose B is your table which is having P1, P2, P3, P4, P5. This is your B. P1, P2, P3, P4, P5. P1 is occurring here, here. So S1, S2, P1, S1, S2, P2. P2 is occurring S1, S2, S3. S1, S2, S3. P3 is occurring S1 only. P4 is occurring S1 and S4. Sorry, P3 is occurring in S3 on S1 only. Sorry. This is S1. P3 is occurring for S1 only. Right, see, P3 is occurring in S1 only here. P3. And P5 is occurring in S1 and S4. So right, so now if I do, which is common, S1 is occurring in everyone, yes. S2 is occurring in everyone, no. S3 is everyone, no. S4 is no. So S number, okay. Ma'am, if B has P6 too, here P6, then C for P6 you have, for P6 you have S1, nothing else. So here I will write P6 will have S1, then also same result, right? Okay. P8. P8 does not have any existence in A table, so it will not be considered. Okay. Division operation is more or less clear. See, division operation is not much needed, but though it is present, so I am telling you. Okay, so you can think it like this: A divided by B, where A is S number dot P number by P number, then it is S number. A divided by B, the result will have S number. Okay, is this clear? হয়েছে, এতটা বুঝেছো? Everyone has understood this? Next we will move to Cartesian product, but before that we will take a 5 minutes break. Yes, almost. Yes, obviously almost, because you need practice and then only you will be able to do it. So we will take a 5-minute break. No one will leave the meeting, be in the meeting. We will meet at 10:35. Okay, so after we finish the relational algebra, then we will take another break. Okay, so relational algebra still, Cartesian product and joins are remaining, so quickly take a 5-minute break and again you be in the meeting. So do not leave the meeting. If you leave the meeting, your attendance will be hampered. Understand that. Okay, so be in the meeting. We will just be back in 5 minutes.
Recording stopped. Recording in progress.
Okay, so let us start again. Now we will be starting with the Cartesian product. Now see, why we require these product joins, these type of things. Suppose the data that we require in as your output, that data is not present in one particular table. Suppose I require the collaboration of 2 or more tables in order to get my output done, right? So in that case, we require the help of these type of things, which we call as products, joins, and so on. Okay. Now, the first thing that we study is named as the Cartesian product. Now you see the basic details that it's a binary product. That means it operates in 2 tables, more than 2 tables, and it's a fundamental operator. So no other operator can work as the Cartesian product. Okay. Now how it works? For that, let us understand. Let us take the example. Suppose now if I write in normal mathematical sense, if I write A cross B, what it means? Each element of A will be taken and will be combined with each element of B. And then next element of A will be taken and will be combined to each element of B. So how your A into B will look like? 1, 2, 1 from here, 2 from here, 1, 3, 1, 4, 1, 5, comma 2, 2, 2, 3, 2, 4, 2, 5. Okay. So here you can see that each element of one table or one set, here we are doing it set wise, right? So each element of one set is taken and it is combined with each element of the next set. Similarly, when it is done, next element of table 1 or set 1 will be taken and all elements of table 2 or set 2 will be clubbed together, right? So this is what your Cartesian product is. Now we say that Cartesian product has got ordered pairs. Ordered pairs. You see this portion? It is having ordered pairs. That means what? If I have done A into B, right? If I do B into A, the result will be different. All elements of B is taken and clubbed with A. Sorry, a bit of difference. 2 is taken clubbed with 1 and 2. 3 is taken clubbed with 1 and 2. 4 is taken and clubbed with 1 and 2. 5 is taken clubbed with 1 and 2. So here you can see the order of the pairs. The order of the pairs are different if you multiply them or if you perform Cartesian product between 2 tables or 2 sets in 2 different ways. I hope you see the difference. So Cartesian product is like this. Nothing will be eliminated. Nothing will be deleted. So how they will be done? one item will be taken and it will be clubbed with every other item of the other set. That other set can be of table, the other set can be of set or anything like that. Okay. So this is how your Cartesian product will look like. Now, if we come to the Cartesian product in case of tables, R1 and R2, here you can see. So let us take a small example and let us see that how it works. Suppose R1 is having A, B, and R2 is having, suppose, C, D. Okay, names will not matter. Here AB can also be there. 1, 2, 1, 3. Here suppose 5 C, D, E. 5 X, Y, 2 A, B, 3 P, Q. Suppose this is what. Now if I do R1 into R2, my resultant will be this will be taken to this, to this, to this. This will be taken to this, to this, to this. Okay, so what will be my result? 1, 2 will appear thrice. 5xy, 2ab, 3pq. Right? Then 1, 3 will appear thrice. 5xy, 2ab, 3q. So this is how your Cartesian product will look like. Okay. So it does not matter what the column names are. It will be just a clubbing of all the elements together, but in an order. Now, if you do R2 cross R1, then your resultant will be C, D, E, A, B. Okay, so it will start with 5xy, 1, 2, 5xy, 1, 3. Then 2ab, 1, 2, 2ab, 1, 3. Then 3pq, 3pq, 1, 2, 3pq, 1, 1, 3. Okay, so you can see that the order of R1 into R2 if you do, and if you do R2 into R1, the result is different. Ma'am, then how is it becoming a pair in the tables? This is how they are becoming pair here. This is a pair, this is a pair. So it is put by comma like that. If you do it in mathematics, it is coming like this. If you do it with respect to table, this is one particular set and this is one set. So this is multiplied to this one first and this one then. That is how, right? So hence this is named as ordered pair. Okay, so Cartesian product is also named as ordered pair. Now see the example here. Find the customer number having account balance less than 1000. In the account table, I have account number, branch name, balance, and in the depositor table, you have customer number and account number. Up to now, whatever we had done, within one table only we have found all the details. But this one, you see, in the account table, I have account number, balance, but I don't have customer number. In the depositor table, I have customer number and account number, but I don't have balance. So in my output, I require customer number, but the criteria will be on balance, right? So how you will do? So here comes the concept of Cartesian product, right? So here how we will say customer into depositor, sorry, not customer, account. Account into depositor. From there, we will be fetching balance less than 1000, the customer number. Right? Now see what this one will give you, what type of output we will see. Account number, branch name, balance, customer number, account. So based on the account account table, it will be multiplied to depositor table, right? Based on the account table, it will be multiplied to depositor table. So let us see how it works. This particular one, this particular inner table, how it forms. Account number, branch name, balance, customer number, and account number. Okay, 101x 500, 101, 2102, 3103. Right? Next 102. So this will be repeated. Y 700, 101, 2102, and 3103. Next one 103, Z 101, 2102, 3103. Right? So this is my output from the inner table. Now what they have told? Balance is less than 1000. So balance less than 1000 is these three cases. There are three cases, right? So I have not written them, but there are three cases. So here 3 cases and here 3 cases. That means 6 cases, right? So 101x, 101x, and 102y, 102y, right? So 1, 2, 3, 1, 2, 3. 6 outcomes are coming by this particular query. And then they are asking for the customer number. Customer number. So customer number is 1, 2, 3, 1, 2, 3, 6 rows. So 1, 2, 3, and 1, 2, 3. It will not be repeated. So my answer will be 1, 2, 3. Right? Now see here, when this 103, 1000, 103, 10,000, sorry, 103, 10,000 is getting mapped with these three. Everywhere I am having 10,000. So that there your balance is greater than, but I require my balance should be less than 1000. That means all the cases whenever I am having 500, 700, in those cases only I am fetching my output. But is it correct? 103, the customer number 103, if you look at the table, customer number account number 103 is having balance 10,000 if you look into it properly. But here many tuples are getting generated which are unnecessary, like the tuple which is having 101 Z, sorry, 101x, not Z, 101x 500 3103. In this one, once my customer number, once my account number is 101 and once my account number is 103. So here there is a problem we can find where my customer number is a common thing. In the two tables, my account number is a common column. But when you are trying to do the Cartesian product, your account number is getting duplicated. There is no elimination, right? In Cartesian product, everything will be present in my output. So account number is getting duplicated. Now, when your account number is getting duplicated, your account number here in this particular, this is one tuple that will be generated in the output. Once your account number is becoming 101, in the same tuple, your account number is showing 103. So this particular type of tuples are not right, they are wrong tuples. We call them as surplus tuples. We call them as surplus tuples and they must be eliminated. These are not right. Customer number should either be 101 or it should be 103. It cannot be 101 and 103 both at the same time for one customer, right? So the cases where we are getting this type of problem, we call them as surplus tuples. We call them as surplus tuples. Yes, I am repeating. In this table, you see the output table. Suppose this particular one or this particular one tuple where your customer number is once 101 and once it is becoming 102 because of the multiplication. It is 101 here, 103 here. Similarly, here in this tuple, it is 102 here and 101 here. An account number for one customer, it cannot be different in two different columns. It should be same. But in case of Cartesian product, when we are doing blind multiplication of tuples, row-wise multiplication, we are finding this type of problem. These type of tuples where some mismatch of values are present, we call them as surplus tuples. And they must be eliminated. So if I do account into depositor, the thing that is coming, I have just explained you. Now, what is surplus tuples or surplus records? I am explaining you. If one particular column, that is suppose account number here is a common column in both the tables. Now, account number for a customer cannot be different for different cases. It should be same. So in those particular query or in those particular tuples where they are being different, they are being named as the surplus tuples or unnecessary tuples. So we need to remove them. How we will remove them? We will learn in joins. Okay, so after Cartesian product, we have joins. So here also you can see one example is being shown on screen. One random Cartesian product example that I have already explained was few of you. So you can just see every tuple of R is taken and are getting multiplied to every tuple of S. Okay, every tuple of R is taken and it is getting multiplied with every tuple of S. So that is your Cartesian product. Fine. So if you apply Cartesian product without any constraint or anything, so Cartesian product will give you this type of result where some confusions may arise and hence we generally avoid Cartesian product. Until and unless we don't know joins, we will use Cartesian product, but Cartesian product gives us bad result. Yes, Cartesian product is a bad practice. It is not very much used. Okay, but before going into joins, we have to understand Cartesian product so that we are explained. Now come to joins. Cartesian product, if being modified with some criteria, then we call them as joins. Suppose in this example, if I write the query like this, where account and depositor both are having account number So if I say account dot account number equals to depositor dot account number, on this will be my criteria, on this my account into depositor will be done. So let us see what will happen. You are understanding the criteria? Account dot account number equals to depositor dot account number. If I do this, then what will happen? Let us see the table. Suppose what will be my output? It is Cartesian product. So what will be my output? Account number, branch name, balance, customer number, and account number. So what they have told, account number should be same. So 101 account number, branch is X, balance is 500. When the account number is 101, what is my customer number? 1. Understand this. When my account number is 101 in the table, see the table. See the table. When my account number is 101, if you look into the depositor table, what is your customer number? 1. That means what? If I say account dot account number and depositor dot account number, then only one tuple is getting generated by 101. That is with customer number 1. Similarly, when my account number is 102, when my account number is 102, in that case, my customer number 2 is getting generated only. 102 to 102 of depositor. Similarly, for 103, where my account number is 103, in my depositor table, account number 103 is having customer number 3. So only 3 results will be generated. Y 700 to 102, 103, Z 3103. Now you look at to the table, see there is some similarity. Now if I say the balance is less than 500, take out my customer number. So sorry, less than 1000. So this is less than 1000, this is less than, so customer number 1 and customer number 2 are having balance less than 1000. Okay, so this type of criteria, if you apply this type of criteria, then we go towards join. Okay, so if you follow this type of criteria, then we go towards join. Fine, now we will understand that what type of joins do we have. Have you understood this criteria matching? Okay, now joining means when you are applying some criteria. Suppose account dot account number, in the account table you have account number, in the depositor table also you have account number, right? So when you are trying to map the account numbers, and then only you are trying to find out the customer number or something, then what you are doing? Account table, this is table name dot column name. You are applying an equals, that means you are trying to map with table name and column name, right? So if you are doing this, you are getting this particular table where your account number is getting matched with another account number. Yes, I am explaining with another example. Suppose, see this, See this one. Student table and subject table. Student table and subject table. In the student table, you have SID, SNAME and standard, STD. And in subject table, you have class and subject, right? Now, if I apply my criteria, that is student.std equals to subject.class, that is student.std equals to subject.class. Whenever they are equal, then only I will apply the join. See, the column names are different. STD in student table and class in subjects table. But I am trying to map them. Then you see what is happening. You take a screenshot or picture of this one so that when I write it in the paint, you can get the idea what is happening. Take a picture or screenshot. Now, if I say that on this particular criteria, you join the tables or you cross product the tables. This is your criteria on which you are doing okay. So what will be your outcome? SID, name, STD, class, subject, right? 101, Alex, 10. In 10 you have 10 here with math. And similarly, again, you have another 10. So Alex will also study with subject English, right? Next one, you have 102. You have Maria, 11th standard. So in 11, that person will study music. 102, Maria. This person will study along with music. That person will study sports. So here you see, if the column names, even if the column names are not same, then also your based on the equivalent criteria. So you see 10 is getting mapped with 10 only. 10 is not getting mapped with 11. If you do a Cartesian product, 10 will get mapped with 10. 10 will get mapped with 11 also. But here if you give an equivalent criteria between columns, then 10 will get mapped to 10 only. Right? So from here, what you can fetch? If you are in 10th standard, you will study maths and English. If you are in 11th standard, then Maria is studying music and sports. Right? So the criteria of joining is what? The criteria of joining is what? You have two tables. You have to identify that which column you have to map. If you try to map the standard, then I am mapping STD with class. Now see, if you say that SID means what? Student ID. I want to map student ID with class. See, that is not possible. SID is 101 and your class is 10 and 11. So that is not possible. If you want, you can write that query, but answer will be null, right? So if you do only Cartesian product, then everything will be mapped with everyone. So you may not understand that from where you will get the exact output. But if you do this type of criteria based product, then we call them as join. Okay. And when your criteria is equal criteria, we call that as equi-join. Okay. So the first one is equi-join and theta join. So theta join means what? theta join is the criteria that you write. What they say, this is your joining symbol, and here you write theta. So theta is what? Theta is the criteria on which you are joining R1 and R2. So suppose T1 join T2 you are doing based on theta. Your theta is what? Theta is the criteria on which you are joining. So suppose if I say standard has to be equals to class. T1 dot standard should be equal to T2 dot class. Then this is should the criteria. So this is your theta. Okay. And when the criteria is equal criteria, we call it as equijoin. Okay. So you see here the example. You see here the query that we are writing. Student join subject. Under the join as suffix, we are writing student.std is equals to subject.class. And this is your answer. Okay. If you are using equality operator, then it is called as equijoin. Okay. If you are using equality operator, then it is equijoin. Next, we come to the most important thing, that is natural join. What is natural join? If two tables have got a common column name, if two tables have got a common column name, then we do not write the joining criteria. We do not write any criteria. We just give the symbol that you see here, that is the natural join symbol, and we write the table names, just the table name. And based on that common column name, the joining will be done. Okay, I'm showing you example. First, you understand that up to now, whatever joins and other things we have learned, in case of theta join, in case of equijoin, what we were doing, two tables are present. We are trying to impose, we are trying to write a criteria based on which the joining will be done. So T1 dot standard is to be equal to T2 dot class. Then only the join will happen. Again, if the joining criteria is equal, then we call it as equijoin. Okay. So this is your theta join, equijoin, Cartesian product. If you apply some criteria, this is that. Now, if you just write T1 natural join T2, this is your natural join. So what will happen? T1 and T2 must have a common column name. Suppose X must have a common column name with same data type. It must not be like T1 and T2 both are having X column, but X in T1 is having integer type of data and X in T2 is having character type of data. That is, if that is present, then joining is not possible. Answer will be null. So what will be your criteria? See here, if you look at an example, in natural join, we do not provide any criteria. See here, CID course DEPT department, and in HOD department and head, these two are present. So if you do natural join, you take a screenshot of this one. See here, if you write, if now you write courses natural join HOD. So you're trying to find the HOD name. So what will happen? CID course DPT. DPT is the common column name and it will not be repeated. It will not be repeated. And the name of the head. Okay. So CID CS101 course is database. Department CS. Who is the head of CS from the HOD table? Alex. Next one, Amy 101, mechanics. Department is Amy and HOD is Maya. Double E01, electronics. Department is double E, HOD is Meera. Right? So there must be a common column name, and the common column will be repeated only once, will be written only once, not repeated. It will be written only once, and the criteria or the you can say the matching done whenever, that will be reflected in the output. Suppose in the course table, look at the table now. Suppose in the course table I have BT01 bioinformatics, department is biotechnology, but in HOD I don't have any entry for BT. Then that BT will not be reflected in the output. Suppose I have one entry in courses as biotechnology, but that is not, no head is provided for BT in the HOD table, suppose. So BT will not be reflected in the output. BT will not be reflected in the output. Okay. So there must be a common column present in the tables for natural join. The data type of that column must be same in both the tables. And when you are joining for the common data that is present, like CS, ME, EE, there are common data in HOD also. But if I introduce one BT and the BT data is not present in the HOD, then that will not be shown in the output table. Okay. Right? So if my case is like this, if suppose natural join is clear to all of you, in which cases I will apply theta join, in which case I will apply the natural join, is it clear? If the column names that I want to compare are not same means the column name is not same, data type has to be same. If the column name is not same, then we will use theta join, equi join, those things. If the column name is same, then we can use natural join. Okay, is it clear? Okay, theta join, yes, I'm repeating theta join. Theta join is, suppose here if you have two tables and the table column on which you try to perform the join, the matching that you want to do, that column name is not same. So in the student table it is STD standard, and in the subject table it is class. So you want to compare them. So you will write students.std and subjects.class. If they are equal, then only you will perform. And this equality you will write in theta. So theta is what? T1.std equals to T2.class. Mane students.std equals to subject.class. If they are equal, then only the joining will happen. Okay. And in case of natural join, no criteria must be given. The criteria is inbuilt because that is natural. What is the criteria? The column name. The column name should be same in both the tables, and the data type must be same in both the tables. Okay. All equijoin are theta join. Yes, all equijoin, whenever in theta you apply equality operator, then that becomes a theta join. Sorry, that becomes an equal join. Okay. Natural join, Cartesian product, have you understood the difference? Theta join, natural join, have you understood the difference? Okay. Okay, now see, now we'll come to the next one. That is what I have told you, that if suppose in a table I have any extra tuple that is not present in other tuple. Suppose I have T1 and I have T2. In T1, okay, suppose I have 1, 2x, 2, 5y, 3, 7, z. Here in D, suppose I have x7, z2, w3. Now you see this one and this one. Okay, please understand these are column names. Okay, so C column is common in T1 and T2, and C column is having character type of data, so I don't have any problem, right? Now see, after this, if I write what will happen? Common ones will be fetched. Is there any Y? No. 3, 7, Z2. W3 is not present here, so it will not be present. This is your natural join. Have you understood? Up to this, there is no problem. Up to this, is there any problem? This natural join is clear to all of you. I'm expecting some answers. Yes, no. Okay. See here. Yes, I'm repeating. 1, 2, 8. See, C column is common. That is okay. Now, C value in T1 is X, Y, Z. And C value in T2 is X, Z, W. So, Y is not existing here. And W is not existing here. So, we cannot match them. Hence, they do not come under the natural join output. Okay. Yes, there we cannot use natural join if there is no common column. Column should be same, column name, right? Column name should be same and column data type must be same. Okay. Now you see in ABC you have C column and in in T1 you have ABC and in T2 you have CD. So C is a common column and C is having character type of data. No doubt in that. Now in T1, you have the value of C as X, Y, Z. In T2, you have a C value as X, Z, W. Now Y value from T1 is not existing in T2 and W value in T2 is not existing in T1. So my result is like this. That means 2 rows. 1 row from T1 and 1 row from T2 is eliminated. Now, what if I want that they must be present in my resultant table? Now you can see if Y is present in your resultant table, what will be the value of D? There is no value of D present. That type of join, we call them as outer join, where all values will be present irrespective of their values not existing in the other table. So if I say outer join, there are 3 types. So first let me introduce left outer join to you. It is denoted as left, so an outer way of, this is left outer join. So what is it? All the values, all the rows of T1 will be present in the output irrespective of that value is present in T2 or not. All the values of T1 will be present in my output whether that value is present in T2 or not. So what will be my output? A, B, C, and D. 1, 2, X, 2, 5, Y. 1, 2, X, 2, 5, Y, and 3, 7, Z. Now X is having the value 7 in D and Z is having the value 2 in D. With respect to Y, there is no value present in T2. In T2 there is no Y, right? But as it is left outer join, Y must be present because it belongs to the leftmost table. So I will put a dash. This is left outer join. What is left outer join? It is natural join with the criteria that all values of the left side table, like this, if you write, this is your left side table, will be present. All rows of the left side table will be present in the output. If you do not have anything getting mapped to the right side table, like Y here, you will put a dash. Okay, the values which are getting mapped, for them it is okay. The value which is not getting mapped, for that value you will put a dash in the right hand side tables column. Okay, so Y is not present in T2, so Y is written as a dash, right? Similarly, if you do the right outer join, it is denoted as right hand side outcurse. So what is it? So right hand side table, all rows will be present. So X7, Z2, W3, X7, Z2, W3. Now, whichever are getting mapped to the left hand side table, we will write them. X is mapped to the left hand side table, 1 to X, and Z is getting mapped, so 3, 7, Z. So 1, 2, and 3, 7. 1, 2, 3, 7. W is present, W3 is present in my right hand side table, but W is not present in my left hand side table. W is not present. As this is right outer join, I have to include W and I will put dash, as there is no value present in the left hand side table for W. Okay. So what is outer? Yes, null values, dash value or null value. What is outer join? See, from natural join you start. T1 and T2, these two are two tables having a common column with common data values, fine. But T1 is having some rows which is not existing in T2, and T2 is also having some rows which is not existing in T1, fine. Now, if you apply natural join, then in the natural join table, all the values that are not existing either in T1 for T2 and T2 for T1, they are getting deleted. But what if I don't want them to get deleted? I want that their values will be present, all values will be present, but if there is any value for left hand side table which is not matching with right hand side, or right hand side table which is not matching with left hand side, then the non-matching columns will be expressed as dash. Non-matching columns will be expressed as dash. In those cases, we opt for outer join. So first type is left outer join, where all the rows of the left hand side table will be present in my output table, if there is any non-matching value from left hand side to right hand side, then that particular rows column of the right hand side table will be put in as dash. Like you see, the left hand side table value is 12x, 25y, 37z. So you write every one in your output, right? Now in the right hand side table, you have a value for x, you have a value for z, you have a value for w, but you don't have a value for y. So y in your output will be put in as the dash in the D column. Okay. Similarly, right outer join, just the reverse, all the rows of the right hand side table, all the rows of the right hand side table will be written in your output table, but those which are not having the values in your left table, those columns will be written as dash, right? So W3 in your right hand side table, W3 in your right hand side table, you see, is not having anything in the left hand side table. W is not existing in the left hand side table, right? So when you join, what will be the value against W? Dash dash. Okay. So easy way to remember, left outer join, all the rows of the left hand side row, you write them, and for which you do not have any right hand side tables value, you put them dash. In case of right outer join, all the values that you have from your right hand side table, all the rows from the right hand side table, everyone you write, for which you do not have any value in the left hand side table, for them you put dash. This is left outer and right outer join. Now last one, you come to full outer join. All the rows of all tables participating, all the rows of all tables participating will be present in my output column, output table, and whichever are not matching in whichever side will be put as dash. So see here, 12x, 25y, 37z, 12x, 25y, 37z, everyone is written, and in the T2, x7, z2, w3, x7, so x is present, so 7, z is present, so 2, and w3. So the ones which are matching, I'm writing with respect to them. The ones which are not matching, those I will put dash. So full outer join is a combination of left and right outer join. Okay. So A, B, C, D, all columns are present. Whatever rows you have matching, you first write everyone. If you don't have anyone matching, then the non-matching places you put dash. That is full outer join. R1 number of columns greater than R2 number of columns? No. It is not like that. There can be any number of columns. Is right outer join is just reverse of, yes, right outer join is just the opposite of left outer join, and full outer join is a combination of right and left outer join. Okay. Now you look into the example given in the slide. Outer join, you go to the theory, don't need. Now see, left table and right table, they have named it like that for your ease to understand. So left table is having 100, 101, 102, and right is having 100, 102, 104, right? So if it is a left outer join, all rows, all 3 rows of left table will be present in my output. Fine. Now which table? 100 is having the value as Alex, so they have written it like that. 102 is having electronics and has Maya, so they have written it like that. Now 101 mechanics, this does not exist in the right table, so they have put dash. Okay, 101 mechanics does not exist in the right hand side table, so they have written dash. This is left outer join. So all the rows or tuples of the left hand side table will be present in your output. The ones that are not matching on the right hand side table will be put in as dash. Okay. So course left outer join HOD. In course 101 mechanics is extra, that is not having any existence in right hand side table, so we have put in dash. Similarly, if you look into the right outer join, you see same table. If you look into the same table, right outer join, then right hand side tables, all three rows will be present in your output: 100, 102, 104. So Alex, Maya, Mira all are present. Now 104 Mira does not have any existence in the left hand side table, so no subject for Mira. So you can see with Mira it is put in dash. Okay, as the column names are different, so all the column names are given. Okay, next one, full outer join. You can see all the rows of left hand side and right hand side both are given. Whichever is not having any value in right hand side, it is put in dash. If it is not having any value in the left hand side, then it is put in dash in the left hand side table. Okay, now you can ask that in which type of questions do we use full outer join. Everything will be done in natural join, right? So in what type of questions do we do full outer join? Suppose it is being asked that I have a course list and I have an HOD list. Which courses are not assigned to HODs right now, right? Or suppose some HODs have left, and after that the question arises that which courses are not having any HODs. So I have to show it like this. Left table should be course, right table should be HOD, and if there is no HOD, there should be blank. So all, if I do left outer join and I keep course on my left hand side, then all courses will come in my resultant table, and the courses which are not having HODs will be kept as blank, right? So there I can show that yes, there are some courses where HOD is not assigned. Okay, so in those type of cases, you have to understand and you have to answer. Okay, done. So these are your types of joins and Cartesian products, whatever you have in your relational algebra. Fine. Now, based on all the things that you have learned in relational algebra, selection, projection, union, intersection, etc., everything joins, we will proceed towards the SQL, but we will do SQL in the next class. So today we will start very basic things that will lead us to the normalization. We will start with functional dependency. Okay, so I'll just stop sharing my screen. So I'll start that after 5 minutes. So 5 minutes I give your brain to have some rest, and then we will just start. Okay, so don't leave the meeting again. If you leave the meeting, your attendance will get hampered. So be joined. We will just be back within 5 minutes and we will just start the functional dependency. Very basic. That is not very difficult, very easy. So we'll just start the basics so that next day we have some time savings. Okay, so we'll just be back in 5 minutes. You be here in the meeting, do not leave the meeting. I'll just come back within 5 minutes and start.
Recording stopped. Recording in progress.
Okay, so let us get back. Now, first query that I have got is, ma'am, can you explain about the inner query, inner joins? So understand, the total set of joins are divided into two parts, inner join and outer join, in some of the materials or books, right? So outer joins are those where means output is coming whenever there is no match, then also the output is coming. But in case of inner joins, there will be some matching criteria, and based on that only the output will come. So inner join automatically covers all type of theta join, equi-join, natural join, and cross join, means Cartesian product with some condition, right? So whichever join we have some condition matching criteria, that is inner join. So that the intersection is coming, that is inner join. And whenever it is like that, that other than the intersection other part will also come, that is outer join. So just let me show you. Suppose this one, suppose this is one wait, suppose this is one table and this is another table, and you put some criteria based on this. This is coming, this is your inner join, right? And outer joins are which? The inner talk will come, no problem, but suppose the left one is coming. So this is left outer. If suppose this is the case where this is coming and along with this is coming the right hand side. So this is right outer. Okay. And somewhere if everything is coming, then we call it as, either you can call it as Cartesian product or you can call it as full outer. Okay. This is the difference. Whenever you are putting some criteria, it comes in inner join. Okay, inner join can be your natural join if column names are same. It can be theta join or equal join if the column names are not same, but you are comparing two columns and making them equal to be joined. So that is inner join. It is not always intersection. If it is natural join, then it can be intersection, but intersection we must not say, because in intersection total row wise matching should be done. But in case of join, only one particular column value we are matching, right? So it is not always intersection. You can call it like intersection, but actually it is not intersection operation. Join is not intersection. Okay, I hope that is okay. Inner and outer join difference, have you understood? To the people who were asking, yeah, okay, they have understood. Now one more query I have got, that ma'am, please provide some practice problems. Yes, see, I am doing all the joins and everything using examples only, but though if you need all more examples, then okay, I can provide you some practice set that you can follow. And the PPTs, yes, I will provide the PPTs, but please understand, from PPTs you will not learn, right? So the examples that we are doing in the class, if you interact and if you understand, try to pay attention, then I hope you will learn. Okay, PPTs and practice sets I will provide, don't worry. Okay, so now can we proceed towards the next thing? Next, what do you call the functional dependency? Okay, so just wait for a second. Now, see, the first term that we hear is the functional dependency. Now, what is a functional dependency? Suppose in a table, I have two columns. Now, in each of the column, I have some values, some rows. Now, Suppose you take the example here, like I draw. Suppose I have a table. I have two columns A and B. I have x1, y2, z3. Okay. Now, what do you mean by functional dependency? FD. FD is represented as A to B, column A determining column B, in the sense B value is not computed by the value of A, but the value of B can be searched by the value of A. Value of B can be searched by value of A. So, whenever I find A equal to X, my value of B will always be equals to 1. Then I can say A to B is a valid functional dependency on relation R. If the table name is R, whenever you find a value of one column and the same value of with respect to that column, if you find in the other column, that will be repeated in every instance, then we call it as the functional dependency, right? So check here. I will show you few slides, though we will complete these things next day, but though to give you an idea, see, the functional dependency that we call, it is all about the column, you can say the column dependencies, where if I say A to B is a functional dependency, then value of B, that is the arrowhead, towards the arrowhead, whatever column name we have, that column's value is not computed or calculated by A. But if I have the value of A, I can search the value of B, right? It is a logical type of dependency. Okay, so what I can say, the formal definition you can see here. If A equals A is determining B, then tuple of A is equals to tuple of B whenever, that means if X is repeating itself, then with respect to X, whatever value I have, that has to repeat itself. Suppose if you have A and B, in A you have x1, y2, z3, w4. Again, whenever you have y, your value will be 1. If you have z, then value will be 3. If this is the case, then only we can say A is to B is valid. Sorry, this should be 2. For every value of A, for every value, T1 means what? Tuple 1 of A, if equals to tuple 2 of A, that means this is your T1, this is your T2, this is your T3, this is your T4, this is your T5, this is your T6. T means tuple. Tuple meaning one row. Tuple means one row. So if my T2 is equals to my T5, then T2 of B has to be equal to T5 of B. Whenever my tuple value is repeated for column A, the corresponding tuple value of column B has to be repeated. So whenever I will have Y in my A column, corresponding to Y in my B column, I must have 2 as the value. If so, then A to B is a valid functional dependency. A to B is a valid functional dependency. So whenever you have the value of A is repeating itself, the corresponding value of B must repeat itself. And now you can say if it is not repeating itself, then all value of B can be whatever, does not matter, right? So if in this case, X to 1, Y to 2 and Z to 3, so no one is repeating in A. So whatever be the value of B does not matter, right? So how to check whether a functional dependency is valid in a table? How to check it? There are 2 shortcuts. T5 is not T2, means, oh, here, yes, it should be T2, sorry, it should not be T5, it should be T2. T5 I was just telling, so I have written it by mistake, it should be T2. So how to check functional dependencies, whether they are valid or not? Either the LHS should be unique, then whatever be the RHS, my FD will be valid. Whatever be my RHS, my FD will be valid. If my LHS is unique, in this case, if my LHS is unique, then whatever be my RHS does not matter, the functional dependency will be valid. Another case, or RHS must be constant value. RHS must be constant value. Now see, a table A and B, X, Y, Z, Y. If RHS is a constant value, then whenever A repeats itself, the value of B is constant, right? Whenever, even if the A is repeating itself, the value of B is constant. So A to B must be valid. So what is an FD? What is a functional dependency? For any column of a table, if the other column is dependent on that, then if column A is repeating itself, the value of corresponding value of B should also repeat. That is functional dependency, valid functional dependency. Now, validity of a functional dependency can be checked by 2 ways. Either the LHS of the functional dependency set of the table is constant. So, sorry, not constant, unique. Means it is always new, does not repeating itself. Then whatever be the value of the right hand side does not even matter. If the left hand side is not repeating itself, if it is repeating, then only I have to check the corresponding value. If it is not repeating itself, then whatever be the value of the right hand side does not even matter, right? So that is your one way of checking. Other way, if the right hand side is always constant, if the right hand side is always constant, then whatever be your left hand side's value, even if it is repeating itself, the right hand side is always same. In that case also, the functional dependency will be valid. Okay, so how to check a valid functional dependency? Is it clear to everyone? Have you understood? Is it clear? Fine. Next, we will find out that if a valid functional dependency set is given, if a valid functional dependency set is given on a table, how to determine the closure of the attribute? How to find out the closure of the attribute? See here, closure of the attribute is denoted by A plus or any attribute plus. So how to find it out? Suppose there is a relation. This is how we write a relation. Okay, so A, B, C, D, E are the column names. R is the table name. A, B, C, D, E are the column names. Suppose the relation, the functional dependencies given are okay. Now, if suppose attribute closure, closure of attribute, that means what can be determined from A. A closure means what can be determined by A. Okay. So we will use them and we will write it like this. A closure will always determine A itself, and what else? See, A determines BC. So in bracket we will write using A to BC. Now C is determining ADE. So here I have C, that means C is determining ADE. So AB, then I must write ADE. But as A is written already, so I will write A, B, C, D, E. Okay, you can write in brackets, C determines A, D, E. Okay. Next, see, D determines AE. So D is present here and it is determining AE. Both are already present. So I will not repeat. That means, and there are no other dependencies present. So A closure is equals to A, B, C, D, E. Okay, so how I will find? A closure is directly finding A itself. Then A closure is finding from A, I am finding BC. I am using this one. And I am finding BC. So I am writing ABC. Then B is determining anyone? No. C is determining AD. So I have C. So I will write C is determining C itself and then ADE. Right? But A is already written once. So I will not repeat A. So I will write A, B, C, D, E. Then again, I have D is trying to determine A and E. D is trying to determine A and E. But A and E are already determined. Right? So I will not write them again. So A closure is A, B, C, D, E. Right? Next, suppose if I say C, D closure. CD closure is determining CD itself. C is determining ADE. So A, D is present, I will not write, and E. E is present, AE. AE all are present. Fine. So here C2ADE. Now you see A is determining BC. So A is present. C, D, A, E, B. So A is determining BC. Fine. Now this one CDAEB, this is not in an order. So now the question can arise, should we always write in order? Does not matter. If you want, you can write it in order. If you don't want, you can write it like this also, you will get the same marks, or right or wrong. Okay, same thing. Yes, fine. So how to find attribute closure, is it clear? Attribute closure means that attribute or the set of attributes are determining whom. That is the attribute closure. Okay. The attribute is determining whom. That is the attribute closure. Now it can be a set of attribute also. Like suppose if I say that ABE, what is the closure? So A is determining BC, and E is determining AE. So here I can write it like this. Then C is determining ADE. So A, B, C, D, E. Okay? Is it clear? Is it clear to everyone? Attribute closure is same as closure? Yes, closure and attribute closure are same thing. And we will determining them. If it is a single attribute, you can just write plus. If it is multiple attribute, you put bracket and then put plus. Okay? Okay, now do one thing. You take a screenshot of this one and you try to solve it on your own. Okay? Which functional dependencies are valid? Take a screenshot of this one and try to solve it on your own. Okay, so today we will stop here and next day we will start from the functional dependency checking, the Armstrong's axioms, then we have the canonical cover, the equivalence functional dependency, and then we will proceed towards finding of key and then the normalization. Okay. Yes, I will send the PPT. Have you taken the screenshot of this one? Please practice this at home. Yes, when I come to normalization, I will explain everything. No need to give attendance. If you are done, have you taken the screenshot of this one? I hope you have taken. Okay. Okay, so I'm stopping the screen share. I'll end the class here. Thank you for attending. See you in the next class.